In this class, you will be learning about limits involving absolute value. My name is Janine and I make educational videos like this. If you're interested in seeing more, you know what to do. Please subscribe to the channel. Make sure to hit that notification bell and give me a thumbs up if you like this video. For the first example, we have let g of x, which is equal to x squared plus x minus 20, and this is over the absolute value of x plus 5. So the first thing you have to keep in mind whenever you're looking for limits involving absolute value is to split g of x, in this case, into a piecewise function. In other words, you would have x squared plus x minus 20, and this is over negative times x plus 5. Make sure you include x plus 5 into a bracket because you're supposed to distribute the negative sign. And this is when x plus 5 is less than 0, and hence the negative sign. On the other hand, you have x squared plus x minus 20, and this is over x plus 5. And because it doesn't really make sense to have a positive symbol right beside the bracket, we're just going to leave this as x plus 5. And this is when x plus 5 is greater than 0. Now, because we're able to reduce the terms here by factoring our numerator, we're going to go ahead and do that. So we would have g of x, which is equal to x plus 5 times x minus 4. And this is over negative times x plus 5. And this is when x plus 5 is less than 0. On the other hand, we have x plus 5 times x minus 4. And this is over x plus 5. And this is when x plus 5 is greater than 0. Now we're able to cancel out x plus 5 here. And then on top of that, because you have a plus 5 here, we're able to transpose positive 5 into the opposite side of the equation such that this now becomes x less than negative 5. And this becomes x greater than negative 5. So just rewriting what we have, so we have g of x is negative times x minus 4, and this is when x is less than negative 5. On the other hand, we have x minus 4, and this is when x is greater than negative 5. Now for us to find the limit when x approaches negative 5 from the right, all we do is look for when x is greater than negative 5. In this case, it would be x minus 4. So we would have x minus 4, applying direct substitution, plug in negative 5 into your x, so you would have negative 5 minus 4, and this is negative 9. Therefore, the limit when x approaches negative 5 from the right for g of x is negative 9. On the other hand, if you were to consider the left-hand limit, that means you're really concerned about negative times x minus 4 when x is less than negative 5. So all you do is have negative times x minus 4, plug in negative 5 into x, so you would get positive 9. That means the limit of g of x when x approaches negative 5 from the left is positive 9. For us to identify whether the limit of g of x when x approaches negative 5 exists, there's only 3 things you need to remember. So first, you need to make sure the limit of g of x when x approaches negative 5 from the right, it must exist. Second, the limit of g of x when x approaches negative 5 from the left, it must also exist. And lastly, you need to make sure that the limit of g of x from the right, it needs to equal to the limit of g of x when x approaches negative 5 from the left. However, for number 3, this is not the case because, as we've seen before, the limit from the right-hand side is actually negative 9. In addition, the limit from the left-hand side is actually positive 9. So they're not equal to one another. Therefore, the limit of g of x when x approaches negative 5, it does not exist. Now moving on to part C, we need to sketch the graph of g. So we're just going to copy this and bring that below. So because we're looking at -5, that means you need to have -5 over here. And notice how we canceled out x plus 5, as you can see. That means we do have a hole when x is equal to -5. However, what are the coordinates where we have a hole? Then all you have to do is plug in -5 into your x for both when x is less than -5 and also when x is greater than -5. So in this case, you would have negative, let's just use a different color just so it's easier to see. So this is negative times -5 minus 4. So this is equal to +9. So we do have a hole at -5 comma +9. On the other hand, if we were to consider when x is greater than -5, you would have -5 minus 4, and this is equal to -9. So we do have a hole at -5 comma -9. So for the first one, when you have a hole at -5 comma 9, this is when it's from the left-hand side. And then on the other hand, this is for the right-hand side. So great, so we're going to mark that right now. So this is -5 comma 9. So that's somewhere over here. And we have -5 comma -9, so that's over here. Now looking at your function, which is negative times x minus 4, because you have a negative slope because of this negative sign, that means we expect that this linear function is going this way. On the other hand, if you were to consider x minus 4, that means we're expecting that this function over here is going this way. And by the way, because this is when x is less than -5, that means we're looking at the left-hand side of -5. On the other hand, for the right-hand side, we're looking what happens at the right-hand side of -5. And first of all, how do we find the y-intercept and the x-intercept? So the x-intercept in this case is going to be +4. However, if we're interested about the y-intercept, what this exactly is, all we do is have y is equal to x minus 4 because we're concerned about the right-hand side of -5. So in this case, it's going to be x minus 4. So this would be 0 minus 4, and hence this is -4. That's why we know that this must be -4. And this is the graph of g of x. Hopefully this makes sense. If you do have any questions, please make sure to leave them in the comment section and I will respond to them.